So today we're going to start with a warm-up. We're going to practice linear equations. The first equation to solve this, we would first add. You don't really have to first add 3. You can pick any of the terms to move. The point is to get all the constant terms on one side and all the variable terms on the other side. So if I add 3, excuse me, let me change that color, to both sides, I get 5x equals 2x plus 12. Then subtract the 2x. I end up with, let's go up here, 3x equals 12, so x equals 4, because we divide by 3. To check, you just plug that 4 in for x. 5 times 4 is 20, minus 3 is 17, and 2 times 4 is 8, plus 9 is 17. So we know we have a correct answer there. For number 2, let me move this out of the way a second. I'll put this over here. Put number 3 up here. Okay. For number 2, you're just going to do about the same thing. Not plus 6. Minus 6 from both sides. So you have 11x equals x plus 30. Then I'm going to go ahead and subtract the x. Remember, there's a 1 in front of that x. So that makes this 10x equals 30. When we divide by 10, we end up with x equals 3. Check that by plugging it in. 11 times 3 is 33, plus 6 is 39. And then the same thing. 3 plus 36 is 39, so we know we had the correct answer. And the last one, before we do that one, we have to combine all the like terms on the left-hand side. So we have 8x plus 6x, which is 14x, and then 15 minus 3, which is positive 12. Set that equal to 180. Subtract 12 from both sides. I have 14x equals 168. When we divide by 14, x would equal 12. Check that. 12 times 8 is 96. Plus 15 plus 6 times 12 is 72 minus 3. So 96, 111, 183 minus 3 is 180. So we have the correct answer. Okay, so we're doing that because in the geometry unit, which we're starting today, on April 22nd, or 23rd, excuse me, involves using a lot of linear equations. And the second thing I want to do is just a quick review of some of the geometry terms. So on this page we have different terms, line AB. So when we look over at the pictures, we can see this is line AB because it's a line, arrows on both ends, and it's labeled with the points AB. So that would be box G. A linear pair of angles. A linear pair of angles is a pair of angles that make a straight line. So here's the straight line. These two angles, angles 1 and 2, when you put those together, they add up to 180, which makes a straight line. Coplanar means things that are all in one plane. So the points that would be all in one plane would be box H. And congruent, this is really important. The symbol for congruent means equal in geometry. Like two angles are congruent. They have the equal measures. So that would be F. The symbol for congruent is F. The equal sign with a squiggly line over it. Skew lines are two lines that are not parallel, but they will never touch. So if you look at this box and you picture the top of a box going this way and then the bottom going this way, this line and this line are not parallel, and they will also never touch. So those are skew lines. Complementary angles are angles that add up to 90 degrees. So we can see in box D we have 20 plus 70 equals 90. Those angles are complementary angles. A segment bisector would be box E. I'm sorry, that's an angle bisector. So a segment bisector, this line is bisecting this segment. We know that because these two pieces of the segment are congruent. These two marks here and these two marks here show that those two pieces are the same length, or they're congruent. And then, as I said, box E is the angle bisector. You've got an angle here bisected by this ray, and I know that's bisecting this angle because I have equal angles here. These two dashes are marking those as congruent angles. Okay, so we also have to know how to name angles. When we name angles, we do side, vertex, side, or a point on the side, then the vertex, then the side. The vertex is the point where the two rays that make the angle come together. So in this angle, H would be the vertex. So when we want to name angle 10, we need one of the points on one of the sides. Here's one of the sides, and here's another side. So one of the points on the side is C. We use this symbol for angle. Number 10 would be angle C. You could use B or C. I'm going to go with C. The vertex is K, and then the other point on the other ray is E. You could do it the other way around as long as K is still in the middle. The vertex always has to be in the middle. Okay, and angle 9. Let's erase this. Angle 9 is made up of these two sides. So we see that K is on one side, so angle K, the vertex is E, and then the other side has either H or I. I'm going to go with H. And again, you could do H, E, K also. So that's how we name angles. We also have different types of angles. We're going to learn a lot about different types of angle pairs, but types of angles. An acute angle, if you come down here to the middle of the page or just below the middle of the page, acute angle is less than 90 degrees. A right angle is a 90 degree angle. An obtuse angle is more than 90 degrees. And a straight angle is 180 degrees. Okay, so if I look at angle MLN up here, that would be an acute angle because I can see that it measures 60 degrees. If I do NLP, that's also acute because it goes from 60 to 130, which is only 70 degrees. NLQ, that is going this way 120 degrees, so that's more than 90, so it's obtuse. OLP, from 90 to 130, that is also acute. And MLQ is a straight angle, so that's 180 degrees or a straight angle. So if an angle makes a straight line, it's a straight angle. We're going to skip the bottom part and go on to the beginning of the lesson. So this is where your notes will begin in your lesson. The goal is to be able to use the relationships between linear pairs of angles and the relationship between vertical angles to solve problems. So we're going to learn about linear pairs and vertical angles and a few others. So in your notes you have these boxes to fill in. Go ahead and pause the video and fill those in. We're going to talk more about these later. The key ones here are the vertical angles, and we're also going to talk about supplementary angles. We will be using adjacent angles and complementary angles in our work today, but really I want to focus on the relationship between two angles that are called our vertical angles. And they're vertical angles when you have two lines that cross and you have angles that are across the x from each other. So 1 and 2 are vertical angles, 3 and 4 are vertical angles. Okay. Identify the following. We're looking at a diagram. We've got F as our vertex of all the angles, and then several different rays. We're going to talk about adjacent angles first. Adjacent angles share a side and a vertex, but no other common points. So for instance, if we're looking at angle AFC, you could not use this ray to make an adjacent angle because this ray is inside of the angle AFC. So let's say I want to start with angle AFC, and I want to look for an angle that is adjacent to that. So I want an angle that shares a side and the vertex, but nothing else. So the two sides are CF or AF. CF, we could go with D, and that would be an adjacent angle. Another pair could be angle AFC, and angle the other side of that, this angle is AFE. So you could use angle AFE for the adjacent angle on the other side of that. There's other pairs of adjacent angles in there also. I just started with AFC, so I used that for the two pairs. Now going down to the next question, two pairs of supplementary angles. Supplementary angles add up to 180 degrees. So I need two angles that add up to 180 degrees. And the way to spot that is to take a straight angle, because I know that's 180 degrees, and find two angles that make up that straight angle. So first I'm going to try AFB, and looking at what other angle I would add to that to make 180 degrees, I have to go this far. Well, it would be BFD. So you could use the angles AFB and angle BFC. Okay, if I look on the other side of the straight line and pick angle AFE, which angle would be adjacent to or supplementary to that? Well, we've got this plus this equals 180. So I could say angle EFD would be supplementary to AFE. All right, the last one we're doing on here is the pair of vertical angles. To find vertical angles, you need to find two lines that cross. Not two rays, two lines that cross. So let's see where I have a line. I have a line here, and I have a line here. So on those two lines, I get this angle and this angle across from each other, or this angle and this angle. Those are the four angles that make up the X that the lines form. So let's start with this angle, AFE. Which angle is across from AFE? This angle. So let's start here. We got C, still F as our vertex, and D. So angle CFD. You could have also used AFC and EFD. All right. On the next page, we're just going to talk about linear pairs. A linear pair is important in this lesson because it's a pair of adjacent angles whose non-common sides make up opposite rays. They make a straight line, basically. So those two opposite rays, or that straight line, forms a straight angle, 180 degrees. So we just kind of talked about that with the supplementary angles. I have this angle plus this angle makes a straight angle. And the important point is that if you have a linear pair of angles, those angles are supplementary, which means they add up to 180. So if I had two angles, we'll call angle 1 and angle 2, the measure of angle 1 plus the measure of angle 2 would equal 180. And you can write that in just below this on your notes, so you have that equation to help you solve the problems we're going to do in a little bit. Okay, so the first problem we're going to look at is we've got KPL and JPL, sorry. And the measure of KPL is represented by this expression. Measure of JPL is measured by this expression. So since I know they're a linear pair, I also know they're supplementary angles, which means they add up to, their measures add up to 180. So I can take the two expressions, 2x plus 24 plus 4x plus 36, and set that equal to 180, very similar to that third warm-up problem we did. So when I have two supplementary angles, I add them together and set that equal to 180, then solve. So 2x plus 4x, 24 plus 36 equals 180. Subtract 60, and I get 6x equals 120, and x equals 20. Now, the question is, what are the measures of KPL? Now that I know x, I have to plug that in to the expression to get the measure of KPL. So I have 2 times 20, which is 40, plus 24, is 64 degrees. And then I could do one of two things. Plug 20 into this one, or do 180 minus 64. Because I know this plus this has to equal 180. So if I take this away, that would give me the measure of that. So that gives me 116. It's 116 degrees. If I check, 4 times 20 is 80, plus 36 is 116. Now let's pretend, if you need to stop, go ahead and stop and copy this down because I'm going to erase something here. Let's pretend we don't have these expressions here. And I just told you the measure of this is 45 degrees. I know it's a little more than that. I just made that up. 45 degrees. The way to get this angle, let's say this is angle 1 and this is angle 2. The way to find the measure of angle 2 is take 180 minus 45, just like we did down here, to get the measure of angle 2. So 180 minus 45 is 135. So this would be 135 degrees, if that were the way the problem was presented. Okay, now we're also going to look at vertical angles today. Vertical angles are congruent. That box is what you want to fill in on your sheet. So that means angle 1 is the same measure of angle 3. So angle 1 is congruent to angle 3, and angle 2 is congruent to angle 4. So if I get two vertical angles, and you need to look at your picture to determine which type of angles you have. Either you have a linear pair, which would be side by side that make a straight line, or vertical angles, which are across each other on a X. If you have vertical angles, you'll set, like if I were using angle 1 and angle 3, set angle 1, measure of angle 1, equal to the measure of angle 3, and then solve. Set the two angles equal, there are two expressions equal, and solve. So the measure of angle 1 is represented by this expression, let's say, and the other angle is measured by that expression. So you have 2x plus 21 equals 4x. I have to subtract 2x, and I get 21 equals 2x. So x is going to be 10.5. Now it didn't say, it said to find the value of x, but if I needed to find the value of the angles, I would plug x in. Same thing with the linear pairs. What if I just gave you, go ahead and stop and copy this down because I'm going to do something different. What if I gave you angle 3 and 4? So measure of angle 3 equals 125 degrees. How would I find the measure of angle 4? Well, since these are congruent, the measure of angle 4 has to be the same as measure of angle 3, so that would also be 125 degrees. So two ways you might get it. You might get two separate expressions that you set equal, or you might just be given the measure of an angle, and you should be able to figure out, since vertical angles are congruent, that the angle across from that is also going to be the same, 125 degrees. Okay, that's the end of the lesson for the 23rd of April, and you have a worksheet that goes with that. That was the homework for that day. It's a front and back worksheet. That should be right underneath here. And then we're going to have on the link underneath the video. And then I'm going to start the lesson for the 24th. So you can stop, get ready, do the worksheet, come back to this spot. Copy the diagram onto your paper, then use the given information to find the angles. You have a diagram here. It's important in geometry that you copy diagrams down onto your paper so you can use it to help you solve the problems. In this case, I know that angle HKI equals 48 degrees. So I'm going to find HKI, and it's 48 degrees. It's already labeled for me. So how would I find HKJ, this angle here? Well, I know, because this symbol means that's a right angle, that these two angles have to add up to 90 degrees also, because this is a straight angle, which is 180. So 48 plus what number equals 90? So I just do 90 minus 48, and I get 42. So I know this is 42. I can fill that in on my picture now. Next I have IKJ. What did I do? Oh, I'm sorry. I just did IKJ. 90 minus 48 equals 42. This one we know is 90 because the angle next to it, the adjacent angle, is 90. Sorry. That would be 180 minus 90. So that would be 90 degrees. Excuse me. Now, FKG. So I'm looking at this angle, FKG. Now I think I have vertical angles here. Let's check. This line crosses this line. This is just a ray, so that's not part of it, or a segment. But I have two lines that are crossing, or two segments that are crossing, so I know that these two angles, this angle and this angle, are vertical angles. And we just learned in the previous lesson that if they're vertical angles, they're congruent, so that one is also 42 degrees. So because these are vertical angles, I can say that the FKG is also 42 degrees. Now let's go to FKH. FKH. Well, I know this angle here is 90, and this is 42. So if I added those two together, I would get the measure of the entire angle. So 90 plus 42 is 132 degrees, and that's the measure of angle FKH. FKJ. FKJ. Now I'm looking at this straight line, and I know these two angles make a straight angle, or 180 degrees. So if they're supplementary, right? So I've got 42 degrees here. How would I get this one? Think about that. That would be 180 minus 42, and that's 138 degrees. Hopefully I'm getting these right. I'm doing this in my head. So I can write that, 138. Now all I need to get is GKI. GKI. Okay, so I'm going this way. So I have 90 plus 48. That one is also going to be 138 degrees. Could I have done that as vertical angles? Yes, because this is a vertical angle with this. So you'll notice when we start doing these, there's more than one way to find these answers. You might think a little differently than me or the person next to you, so do it the way that makes sense to you, as long as you're getting the right answer. Okay, so today we're also going to learn about parallel lines and transversals. I forgot to give you the objective for today. But the parallel lines and transversals create several pairs of angles that have special properties. So we have two parallel lines, and we know that these two lines are parallel because of this arrow right here. The arrows on both of them tell you that those two lines are parallel. Not these arrows, those are just telling you they're lines. But if they put an arrow in the middle of a line somewhere, then somewhere on the line other than the ends, then you know that those two lines are parallel. If you don't see those symbols, then you cannot say, even though it might look like it, you cannot say that those are parallel unless you're given that information. Now we've got a line that cuts through those two lines, which is called a transversal. So we know these are parallel lines because of this symbol. And this is a transversal because it cuts through the parallel lines. And you notice that we made several angles because of that cut through. There's 8 special angles there. And we're going to look at the properties of those special angles. The first type of angle I'm going to look at is on the outside. I'm going to use my highlighter here. On the outside of the parallel lines. So I've got angles here. All outside my parallel lines. The inside would be in here. We're not talking about that yet. We're going to do the outside part. Okay, so on the outside of our parallel lines, we've got two different types of pairs of angles. We've got what are called alternate exterior and same side exterior. So I'm going to call this one alternate exterior and same side exterior. because the word exterior means outside the parallel lines, outside of something. So alternate exterior angles, let me add another color for my highlighter. Alternate exterior mean they're on alternate sides of the transversal. So here's my transversal. This one and this one are on alternate sides of the transversal. This one is also, but that's a linear pair. So we already have a name for that pair. It's this pair, this angle, and this angle that we're interested in. And there is another pair, hopefully you can see it, of alternate exterior angles. Think about it. And that would be angles 2 and 7. So you've got two sets of alternate exterior angles. You've got angle 1 and angle 8. You've also got angle 2 and angle 7. Now the special property about alternate exterior angles, let's say you know these are supplementary. Well, and these, since these are supplementary, they add up to 180. These are also supplementary and add up to 180. These two angles are congruent angles, and these two angles are congruent angles. So the property of alternate exterior angles that you would use to solve problems is that they are congruent. Let's look at same side exterior angles. Same side exterior angles. So this one, whoops, I don't want to do that. I want the highlighter. This one and this one are on the same side. And then the other pair that are on the same side, I bet you can figure it out, are this angle 2 and angle 8. So angle 1 and angle 7 and angle 2 and angle 8. Now, the special property about these, I bet if you look at this, you can figure out, are they congruent or are they supplementary? Well, since 2 and 4 are supplementary and 4 is pretty much the same as angle 8, we're going to say these have to be supplementary. And what does supplementary mean? Think about it. They add up to 180 degrees. So if you're solving a problem with same side exterior angles, you would take their sum and set them equal to 180. Whereas if you're using alternate exterior, you would set them equal to each other and solve. Okay, so next we're going to look at what we call corresponding angles. Corresponding angles are either both on top of the parallel of each parallel line or on the bottom of each parallel line. So for instance, let me get my highlighter. Angle 2 is corresponding to angle 6. So look at the picture on the other side. Which angle would be corresponding to angle 1? Angle 1 and angle 5 are corresponding because they're both on the same side of the transversal above the parallel lines. Okay, what about below the parallel lines? Well, angle 4 is just below this side. The other one that's on this side that's below the parallel line, this side of the transversal, would be 8. And then the last pair, I don't know, maybe red, blue, is 3 and 7. So we've got 2 and 6 are corresponding angles. 4 and angle 8, angle 1 and angle 5, and angle 3 and angle 7. Those are your pairs of corresponding angles. Corresponding angles are also supplementary. Corresponding angles are supplementary. They add up to 180 degrees. Those are not supplementary. I just totally lied to you. Those are, erase that. Those are congruent. Okay, 2 and 6 are congruent, 4 and 8 are congruent, etc. The last pair types of pairs are going to be our alternate interior and same side interior. So we've got interior, which is inside the parallel lines. So the interior is in here between the parallel lines. And we have same side, which would be these two like this, or these two like this are on the same side. And then we've got our alternate sides, alternate interior. So 4 and 5. So the interior is between the parallel lines. Alternate means opposite sides of the transversal. Same side means they're on the same side of the transversal. So 3 and 6 are alternate interior angles. Let's change that color. Angle 3 and angle 6. And we also have angle 5 and angle 4. Over here, our same side would be angle 3 and angle 5, and angle 4 and angle 6. So what is the relationship? 4 and 5 are congruent because these are supplementary. These are supplementary. These are congruent. So congruent. And same side are supplementary. Okay, you're going to do a graphic organizer next to organize all this into one place. I just wanted to kind of look at it together before we put it into our graphic organizer. So that's how you would solve problems with same side interior, set them equal. I'm sorry, take their sum equal to 180. Congruent would be alternate interior, and you set those equal. Now here's our graphic organizer. We're going to start with corresponding angles. So if we go back to our corresponding angles, we know that those are congruent. So we can write congruent here. I'm just going to put the symbol for congruent. And which angles in this picture are corresponding angles? Well, we've got two parallel lines here, and we know because of the arrows. So corresponding angles would be like 1 and 5, 2 and 6. Maybe you want to stop the video and try to fill this out by yourself before you look at me do it. That way you'll have to think about it and process the information instead of just copying down what I'm saying. We also have angle 4 and angle 8, and angle 3 and angle 7. So those are the corresponding angles. Alternate interior. Alternate interior are congruent. So those are also congruent. Alternate interior. Remember, they're between the parallel lines, and they are on alternate sides of the transversal. So angle 3 and angle 5, and angle 2 and angle 8. Alternate exterior are outside the parallel lines. Those are also congruent. So far, corresponding, alternate interior, alternate exterior. So the alternates and the corresponding are congruent. So 4 and 6, and angle 1 and angle 7. Okay, and then we also have our same side interior. Both the same sides are actually supplementary. So which ones are same side interior? Well, angle 3 and angle 8. And we also got angle 2 and angle 5. And then same side exterior, angle 4 and angle 7, and angle 1 and angle 6. So when you're solving problems with same side, either interior or exterior, you're going to take their sum and set it equal to 180. The last type, we're just going to go back and review vertical angles in linear pair, because if you look at angle 4 and angle 2, you have vertical angles. So you've got a vertical angles, remember, are congruent, and a linear pair of angles are supplementary. I'm just going to abbreviate that. And we did a lot with those yesterday, so I'm not going to go back and look at all the pairs, but you might want to fill in a few pairs of vertical angles in linear pairs so you can remember. Okay, so how do you use these to solve problems? The first example, find the measure of each angle, given that angle 1 measures 118 degrees. So I'm going to put 118 right here. Now, I know that the vertical angle with this angle is angle 4, so I know angle 4 is 118 degrees. So now what do I do about 2 and 3? Well, 1 and 2 are our linear pair, which adds up to 180. So if I do 180 minus 118, I get 62 degrees. Let's check that. 118, 1920, yeah, that's 180. So since 2 and 3 are vertical angles, I also know that's 62 degrees. So now I have to go back. Do I have corresponding alternate interior, alternate exterior type of angles here? Alternate exterior angles would be like 1 and 8. And alternate exterior angles, going back a page, alternate exterior angles are congruent, and so are alternate interior. So I could go back and fill that in. Alternate interior, these two are congruent, and these two are congruent. Alternate exterior, 118. So I've got it all filled out. So when you get one angle in a parallel lines and transversals, you should be able to get all 8 angles from that one. What if I'm given an expression and I need to solve for x, or solve for the x to get the angles? Well, 2 and 6 are corresponding angles because they're both above the parallel line on the same side of the transversal. Corresponding angles are congruent. So that means I set them equal and solve. So I have 4x plus 7 is equal to 8x minus 1. I'm going to subtract the 4x here. So I have 7 equals 4x minus 1, then add 1 to both sides. And I have 8 equals 4x, and x equals 2. So the measure of this one, well, if I check that, 4 times 2 is 8, plus 7 is 15. 8 times 2 is 16, minus 1 is 15, so I know I did it correct. 4x plus 7. So the measure of angle 2 equals 4 times 2 plus 7, which is 15. Since they're corresponding angles, this also has to be 15 degrees. So that's how you'd use corresponding angles to solve for a variable or solve for the measure. Find the measures of 3 and 5. These are same side interior angles, and remember the same sides are supplementary. So that means the measure of angle 3 plus the measure of angle 5 equals 180. So same side interior, and that is supplementary. So I do x plus 6 plus 3x minus 4 is equal to 180 degrees. X plus 3x is 4x. 6 minus 4 is 2. Subtract 2. I have 4x equals 168. Let's see, I think that's 42 when I divide by 4. So x is 42 degrees. So I plug that in here. 3 times 42 minus 4. 3 times 42 is 126, minus 4 is 122. So angle 5 is 122 degrees. Angle 3 is just going to be 42 plus 6, which is 48 degrees. And I did something wrong here. Okay, so back here, this 180 minus 2 is 178. I apologize. Let's go back and do all this part over. So 178 divided by 4 is 44.5. So now I plug that in. You probably caught me and stopped and yelled at me. Sorry. So I'm going to add 6 to that, so I have 60.5. And 3 times 44.5 minus 4 is 129.5. And the way to check is just to make sure those add up to 180 since they're supplementary, and they do. So I did it right this time? No? $124.5. No? Stop. That's 50. Okay, this was 50.5, and this is 129.5. So now that adds up to 180. Last problem. Oh, that was the last problem. Okay, we're going to stop the video, and you can go ahead and download the worksheets and work on those for your homework. I made a couple mistakes.